Okay, welcome to Unit 2, Lesson 2. These are postulates concerning points, lines, and planes. We're going to do some practice using the concepts that we talked about in Lesson 1. Okay, we're going to practice with the points, lines, and planes, and this is simply getting us ready so that we can identify these when we need to identify them in any kind of problem that we're working. Okay, let's take a look at this. Okay, a postulate is simply a statement that is assumed to be true without requiring proof. Following are some postulates related to points, lines, and planes. Okay, so the first one we have here is that a line contains at least 2 points. This one simply says, through any 2 points there is exactly one line. So you can see there's kind of a correlation between these two. The third one says if 2 lines intersect, then they intersect in exactly 1 point. Okay, this one is talking about planes. Okay, it says that a plane contains at least 3 non-collinear points. This means 3 points that are not on the same line. Planes through 3 points. Okay, there's 2 of these things. Through any 3 points, there is at least 1 plane. If the 3 points are collinear, or on the same line, then there's an infinite number of planes that go through those 3 points. This one says, through any 3 non-collinear, or not on the same line, points, there is exactly 1 plane. Okay, next we have, if 2 points are in a plane, then the line that contains the points is also in the plane. And then lastly, the last of the postulates here is if 2 different planes intersect, then their intersection is a line. Okay, the way that you can visualize this is look at the intersection of 2 walls in a room. Okay, that if you look at the corner there, that is the line where they intersect. The other thing that we're going to be concerned with in this course is this, a theorem. Okay? And a theorem is simply a statement that you must prove before you can use it. Examples of theorems that we will encounter somewhere in this study is this. Vertical angles formed as the result of 2 intersecting lines are equal. The sum of the interior angles of a triangle is 180 degrees. The diagonals of a parallelogram will always bisect each other. The diagonals of a rhombus are perpendicular. And there's many, many more. Okay? Postulates are fairly limited because they're basic ideas that you have to have in order to start geometry. Okay, once you get past the postulates, then you end up with theorems that have to be proven before you can use them. But they're both equally valid in proving a particular construction that you're trying to prove. Okay, let's take a look at some examples then. Example 1. They want us to use this drawing to answer the questions in the following examples. Give one of the postulates on the preceding page to support your answer. Okay, so question 1 is simply this. Considering all the surfaces of the rectangular box, how many planes are being shown? Okay, so you have the front, the back, the 2 ends, the top and the bottom. So you have a total of 6. So there are 6 planes that are shown. Okay, example 2. Name the intersection of planes EFD. So EFD is this plane across the top, and plane DCG, which is this plane right here on the side. So the intersection of this plane and this plane is this line right here, which is line GD. Okay, notice that you need to put the arrow drawn going in both directions. Okay, because it's more than a line segment, because the plane extends out and the line extends out both. Okay, if 2 different planes intersect, then their intersection is a line. That's the postulate that's being used here. Okay, example 3. Are the points E, J, and C coplanar? Okay, they are not linear, so they're not collinear. So this means by definition we have the answer of yes. And the reason why is the postulate that we talked about just a minute ago. Through any 3 non-collinear points, or not on the same line points, there is exactly one plane. So you could have a plane that, even though it's not drawn, is already there, even though it doesn't show it in the diagram. Okay, the postulate says that there has to exist a plane there. Okay, example 4. Do points A and J determine a line? Okay, so there are 2 points. So by definition, what we said is it has to be yes. And the postulate that goes through that says simply through any 2 points, there is exactly one line. So the line AJ goes through the points A and J. Example 5, they want us to name the intersection of plane FGB. Okay, so FGB is this plane that's running across the front, and line AH. Okay, so they intersect at point A. Because the intersection of a plane and a line will always be a single point or the whole line, one of the 2. How many lines are there passing through the points A and D? Okay, notice there's not any shown here, but because what they told us was through any 2 points there exists exactly one line, we know what? There is just one. And the postulate that goes with that is what we just talked about. Through any 2 points there is exactly one line. Example 7. How many planes are there passing through the points A, J, and B? Okay, so A, J, and B are all on a straight line. So that means they are collinear. So there are infinitely many planes going through that line. Okay, and the postulate that goes with it simply says if the points are collinear, there is an infinite number of planes passing through them. So you have the plane that's coming through here, the plane's going this way, another one going back this way, you got one going every which direction here. One of the things to note is just because they don't show it here doesn't mean that conceptually it does not exist. Example 8, they want you to name the intersection of line AJ, which is this line right here, and line BC. Okay, since they got the arrow on both of these, what this means is it extends infinitely in both directions, and this extends infinitely in both directions, so they intersect at point B. Okay, and that is simply the postulate that says if 2 lines intersect, then they intersect in exactly one point. Okay, example 9. They want to know, is line AE in plane AHF? Okay, AHF is this plane that's on this end of the box, and AE goes across that end of the box. So the answer to this would be yes. And once again, if 2 points are in a plane, then the line that contains the points is also in that plane. Okay, example 10. Which planes contain both line HC, which is this line right here, and line CB, which is this line right here? So how many planes are both of those in? They're in just simply plane ABC, which is this plane on the base. Okay? And the reason why that's true is because another thing that they did not tell us in this is that if 2 lines intersect each other in one point, that also creates a plane. Okay. Then right here, they want to know, does ray, JA, so that means it starts at J, goes through A as far as you want it to go, does it point toward the left, the right, up, down, front, or back? As you can see, if it starts at J and goes through A, it is only pointing to the left. Okay, this concludes Unit 2, Lesson 2. Thank you very much. Be sure you are ready to come take care of your WSQ tomorrow. We will see you in class. Bring your questions, put them on the parking lot if you need them. Thank you very much. See you tomorrow.